Let's say you have to take the integral of sine squared of x cosine squared of x dx. And you're starting to memorize some trigonometric identities if you don't have a bunch of them memorized already, or maybe you have to have them memorized. How would you approach something like this? The first thing I might have tried back in the day was I would have tried to write this as the integral of, I would have tried to use this identity perhaps, the integral of sine squared of x cosine squared of x dx, and replaced the, let's say the sine squared of x. Let's say sine squared theta equals 1 minus cosine squared theta. We could do that from that identity there. So what would happen if we did that, if we replaced sine squared theta with this? So 1 minus cosine squared of x, cosine squared of x dx. And I think about trying to use some kind of U-substitution, but long story short, it's not going to work, right? Because there's nothing to cancel out here. You try to do like u equals cosine of x, du equals negative sine of x dx. It's not going to work, right? So forget that plan. What else can we go with? Let's kind of scroll through this list a little bit here. Sine squared of x, cosine squared of x, sine squared of, I don't see anything quite like that, but I do see this. Sine of x times cosine of y is equal to 1/2 sine of x plus y plus sine of x minus y. Seems a little crazy, but let's see if I can rewrite this a little bit. Maybe I could call this sine of x, cosine of x, cosine of x, dx. Maybe I could call that the integral of sine of x, cosine of x, times sine of x, cosine of x. Well, that would sort of match the formula set forth here. Sine of something times cosine of something else is equal to 1/2 such and such. So that would mean I could replace this with 1/2 sine. Here it says sine of x plus y because we had sine of x and cosine of y, but we have sine of x and cosine of x. So we can write here sine of 2x plus sine of x minus y. Of course, in our case, x minus x. So basically sine of 0. So we can replace both of those. We can write the same exact thing here. Okay, dx. At this point, we might notice that sine of 0 is 0 in both cases. So if I take a step to simplify this, could combine 1/2 and 1/2. I have 1/4 sine squared of 2x. And that's what's managed to survive that process. Even so, sine squared of 2x is not a super convenient integral to do. Nothing up here matches that. Sine squared of theta, no, no, no. Until you realize being very tricky and hiding deep inside this identity here appears sine squared of something, sine squared of theta, okay? 2 sine squared of theta is equal to cosine, 1 minus 2 sine squared theta is equal to cosine 2 theta. And believe it or not, that's going to be the one that we are able to use, and that's actually going to get us somewhere. So let me put this out here, 1/4 integral sine squared of 2x dx. And let's rewrite what the identity is saying. The identity here is saying that 2 sine squared theta, sine squared of something, is equal to cosine of 2 theta minus 1. Rather minus 2, right? Minus 2 sine squared theta is equal to cosine 2 theta minus 1. So 2 sine squared theta is equal to 1 minus cosine of 2 theta. Now, I don't exactly have 2 sine of something up here, but I do have sine squared of something, so I could just say that sine squared of theta is equal to 1 minus cosine 2 theta over 2. So if I just say, okay, well, my theta is equal to 2x, then I can make this substitution wholesale, right? 1/4 integral of 1 minus cosine of 2x. See what I did there with the theta and the 2x over 2 dx. Okay, so this isn't turning out so badly because actually this is simply going to be 1/8 integral of 1 minus cosine of 4x dx. And we really have managed to put ourselves in a position where we can do a fairly simple integral, at least based on what we should have learned up to this point in our Calculus 2 or maybe AP Calculus class. So let's just take this, give myself some room here. I'll try and finish it. Maybe I'll just do it up here in a different color. So we have the integral, or rather 1/8 the integral of 1 minus cosine of 4x dx. We'll say 1/8 integral of 1 dx minus integral of cosine of 4x dx. We'll say 1/8 integral of 1 dx is x. If you want to do this, we could call u 4x du equal to 4 dx, and therefore dx is equal to 1/4 du. So we could rewrite that integral quickly here as the integral of cosine of u. Instead of dx, we're going to write 1/4 du. All right, perfect. A couple more lines and we should be able to square this away. 1/8 x minus 1/4 integral of cosine of u du. And finally, we'd have 1/8 x minus 1/4 negative sine of u. All of this plus c, of course, it was there when I did the x part too. But anyway, one more step. I'm just going to replace the u. I'll make this a plus 1/4 because of the 2 negative signs here. Plus 1/4 sine of 4x plus c. And since I'm out of space, hopefully you can take care of the simplification there.